This is Algebra 1, Homework 7-2, Properties of Exponents, the Quotient Rule. Let's go into problem number 1. All right, notice that we have the same base. Whenever you have the same base, you are going to subtract the exponents whenever you have division. So this is really going to be equal to 9 to the power of 9 minus 6, which is therefore 9 to the power of 3. Final answer, box it. Checking our work, 9 to the power of 3, 9 to the power of 3. Excellent. Number 2, remember if you don't have any power up here, you assume that your power is 1, which means, again, like the previous problem, we have division, which means it's going to be subtraction with the powers. This is 2 to the power of 1 minus 8. Therefore, this is 2 to the power of negative 7. And then because we have a rule here that states we only have positive exponents, we have to take, it's not really the reciprocal, we're going to bring this 2 to the power of negative 7 to the denominator, meaning that we have a 1 left over in the top, and we have a 2 to the power of positive 7. You'll notice that this is the long way of doing it. I wanted to do it just once before I do it the shortcut way. What I could have done was this second path down here. I could have seen in advance that the denominator had a higher power, which meant I would have done 1 over, and I put the 2 in the denominator before I do the subtraction problem. Up here I did 1 minus 8, and down here I'm going to do 8 minus 1, because I'm doing bottom minus top and leaving the answer in the bottom, as opposed to leaving the answer in the top and doing top minus bottom. Both are valid formulas. So I'm going to do 8 minus 1 in this case, which is just 1 over 2 to the power of 7, and we get to the answer a little bit faster. Let's check the work to make sure we got it right. 1 over 2 to the power of 7, 1 over 2 to the power of 7. All right, and number 3, same thing. Notice that the bottom, the denominator, has an exponent that is larger. Well, I mean, it's in terms of the distance from 0, it's the same, but it is a bigger positive number. Therefore, I want my answer in the denominator. This is going to be 1 over 4 to the power of 7, and then I'm going to subtract the top term. That top term is a negative 7, so I have a double negative. Again, the rule that I use is when negatives kiss, they become positive, and this is really 7 plus 7, which means it's going to be 1 over 4 to the power of 14. Final answer, and I'll box that. And let's check our work. Number 3, 1 over 4 to the power of 14, 1 over 4 to the power of 14. All right, switching back to red. In number 4, notice that we have parentheses again because we have a negative base. Whenever you have a negative base, you always leave these parentheses because it might mess you up if you don't have them. I'll explain that later if you would like it. But in this case, I know that the numerator has an exponent that is larger, so I'm going to leave my answer in the numerator. I'm going to say this is negative 10 with the parentheses, and this is going to be to the power of top minus bottom, namely 10 minus 2. So this is going to be negative 10 to the power of 8, and I'll final answer box that. All right, let's check number 4. Negative 10 to the power of 8, negative 10 to the power of 8. Let's go on to number 5. Number 5, now we have some variables going on in the mix. So the general way that I think about this problem is I see that I have some coefficients, and I reduce that fraction. If I had the fraction 4 over 4, I would reduce by dividing both the top by 4 and the bottom by 4. And I'd get 1 over 1, and that's exactly what I'm going to write over here. This is going to be 1 over 1. All right, notice down here my r has no power, so we assume that power is 1, and that means I'm going to check the size of the powers. 4 and 1, well, 4 is bigger, so I'm going to put my answer in the top, r to the power of, and then I'm going to do my subtraction problem. Because I'm putting my r in the top, I'm going to do top power minus bottom power. It's going to be 4 minus 1 here. And these ones I don't really need to rewrite. It's more simplified if I don't write them, and I can say this is r to the power of 3. I notice that a lot of students make the mistake of when do we write these ones and when do we not. Like, for example, why did I write a 1 here if it's more simple to not write the 1? The 1 here has to be left behind because I need it to be a fraction. I can't just write the 4 to the power of 14 because that's no longer in a denominator. To be a denominator, I have to have a numerator. So that's the reason that I have a 1. Otherwise, you typically tend to leave off the 1. So in this case, I just have r to the power of 3. Let's go ahead and box our final answer for number 5 and check. Number 5, r to the power of 3. R cubed, please. Oh, come on. r to the power of 3 indeed. All right, moving back to number 6. Number 6, the way that I'm thinking about this one is kind of like cross-canceling. I see an x in the numerator and an x in the denominator. I can just cross both of those off. So this is another lesson. What happens when you cross something off? What's left in the numerator? You don't put a 0. That's not right, because 0 over any number is always going to be 0, and then this answer is 0. That maybe feels right to you, but it doesn't feel right to me. Whenever you cross things off, what's left over is a 1. And then what's left in the bottom is a 2. The answer here is just going to be 1/2. another way of thinking about this problem, if I want to do it a second way, which I like to do just to demonstrate the mathematical prowess that I have, I can say that this is going to be x to the power of 1 minus 1 in the top, and that's going to be over 2, which is going to be x to the power of 0 in the top over 2. And I've told you before, anything to the power of 0 is going to be 1, and this is going to turn into 1/2. So you can get your answer a few different ways. Again, there's no one correct path in many of these math problems. We're at that level finally. 1 plus 1, and there's kind of only one way to see that path. These have multiple paths. All right, now we have variables with two different bases. I have a u and a v for a base. I guess 2 is another base as well. So just like the previous problems, I'm looking at the coefficient first, and I see 2's. So if I reduce that fraction, I'm going to get 1 over 1. All right, the next variable that I see is a u. There's only a u on the top. There's no u's down here, so I'm just going to recopy down that u. I'm going to recopy u to the power of 3. What about the v's? So when I'm taking a look at the v's, I notice that the v in the numerator has a higher power than the v in the denominator. So I'm going to leave my answer in the numerator, v. And then I'm going to do top minus bottom because my v is in the top. If it was in the bottom, it would be bottom minus top. So top minus bottom is going to be 4 minus 3. Simplify this to u to the power of 3, v to the power of 1. But usually, again, we don't write that 1. We don't write the 1 in the denominator. We don't write the 1 in the power. I'm just going to undo until, yes, right there. That's usually how we write our simplified answer. U cubed v. Let's check number 7. U cubed v, U cubed v. All right, let's jump into number 8. Again, I'm looking at my coefficients here. I'm going to try to reduce that. I can reduce that by dividing both the top by 2 and the bottom by 2. And that's going to reduce the fraction 2 over 1. 2 over 1. I'll leave the 1 for now. I'll simplify it in the next step. What about the x's? Well, I don't see any power here. So when we don't see a power, we assume the power is 1. Now, compare. Which power is bigger for the x's, the 2 or the 1? Well, you can see x squared is bigger. So I'm going to write my answer in the bottom where it is bigger. And I'm going to do bottom minus top because I put that x in the bottom. I'm going to do 2 minus 1. All right. What about the y's? So for the y's, again, my denominator is bigger, so I'm going to put my y in the bottom. I'm going to say y goes down here, and then instead of doing top minus bottom, because I'm in the bottom, I'm going to do bottom minus top, 3 minus 2 for my power, 3 minus 2. And now this should get it correct. Let's see. The numerator is still a 2. In the denominator, I'm not going to rewrite this one because it's simplified to not write any coefficient if there is a 1. X to the power of 2 minus 1 is x to the power of 1. And I'm not going to write that 1 because if I do that, that's not as simplified. I'm just going to write the x. And what about the y? The y is also going to be the power of 1, but again, you don't write the power of 1 because that's not as simplified, and I can box my final answer. 2 over xy, let's check number 8. 2 over xy, we're getting them right. All right, let's jump into number 9. All right, I'm looking at the coefficients. I don't see a coefficient down here, so technically that coefficient is 1, and then 2 divided by 1 is just 2, which is the same thing as saying just recopy down the coefficient in the numerator and ignoring the 1 in the denominator. All right, I'm done with the coefficients. The next letter that I see, the next variable in the base, I see a p and a p, and I'm comparing the powers. I don't see a power down here, so when you don't see a power, you're going to write in a power of 1. Now I can clearly see, yes, 4 is indeed bigger than 1, so I'm going to put my p in the numerator, and then I'm going to do top minus bottom, which is 4 minus 1. All right, p's are all used up. I'm going to go ahead and cross those off so I don't confuse. Well, okay, I have to be careful. If I cross them off, that's kind of the symbolic way of saying cross-canceling. I need to somehow, here, I'll put a check above them. I've done those. All right, let's do the q's. Notice I have a q to the power of 4, q to the power of 4. It doesn't matter. You can put it in the top or the bottom, or if you want to be a little bit of a shortcut taker, you could cross them off, right? Because those are the same. It's like saying 2 over 2, and then maybe there's a 3 right there. You can cross off the 2's. That's the same thing as cross-canceling with our normal arithmetic without variables. But if you want, you could go ahead and say the long way. You could say it's q to the power of 4 minus 4, which eventually you can tell that's going to turn into a 0, and then anything to the power of 0 you just cross off anyway. This thing is eventually going to be scribbled out. I'm doing too much work here. All right, and now I'm looking at the r's. So I'm noticing that the r in the denominator has a higher power. It's a 3 instead of a 2. So I'm going to write my r in the denominator. I'm going to do bottom minus top, 3 minus 2. All right, let's go ahead and simplify this thing. And I'm going to have a 2 in the numerator, a p to the power of 3 in the numerator, and I'll go ahead and write q to the power of 0 just to show my work. And then in the denominator, I'm going to write r to the power of 1. I have another step to simplify. I know it's about to be simplified. Normally, I don't write that r to the power of 1, but I knew I was going to simplify in another step anyway. There's going to be 2p to the power of 3 in the numerator, and as I said before, anything to the power of 0, this is going to go to 1, which is the equivalent of just scribbling it out and only copying down that 2p cubed. All right, so 2p cubed over r. Let's check the answer for number 9, 2p cubed over r. Number 9, 2p cubed over r. Did I not check number 2 or number 6? I just now realized that. Let's check number 6. 6 is a half. All right, I got it. Let's do it in ink. Maybe I didn't. Laser pointer. Maybe I just forgot it altogether. Let's check number 10. Oh, double click there by accident. In number 10, again, I'm first looking at my fraction, 2 over 2, and that reduces because I divide top and bottom by 2, and I just get 1 over 1, which is the equivalent of scribbling that out, or the equivalent of like cross-canceling them. They're all the equivalent, right? Next, I see A's. And it's weird that the A came second there and first there. Usually it's alphabetical, but whatever. Okay, so I have an A cubed and A to the power 4. Notice that the denominator has a higher degree, so I'm going to put my A in the denominator, and I'm going to do bottom minus top. So 4 minus 3. All right, next letter that I see, I guess alphabetically, is a B, and there's a B in the top and the one in the bottom. The one in the bottom is a power of 1 because it has no power, and the power in the top for the B is larger, so I'm going to put my answer B in the top, and I'm going to do top minus bottom, 4 minus 1. All right, and lastly, I have to do the C. I've done that one, done that one, done that one, done that one. I just have a C cubed, and there's no other C anything in the top, so I'm just going to recopy the C cubed in the denominator. All right, let's go ahead and simplify this thing. Again, we're not going to write these coefficients because it's more simplified to not have any coefficients. In the numerator, I'm going to have b to the power of 4 minus 1, b to the power of 3. In the denominator, I'm going to have an a to the power of 4 minus 3, which is 1. But again, we don't write the 1 to be simplified. We're just going to say a. And then c cubed, we're going to copy down once again. And it's really tempting, like, oh, those are cubed and those are cubed. They cross, right? No, they don't. They have to be exactly the same to cross. That's as far as we can get them. All right, b cubed over ac cubed. B cubed over ac cubed. Nice. All right. We're on to number 11. Ooh, I see a power of 0. That's the first thing that I saw. Cross it off. Be careful here. A very common mistake is to cross off 4x to the power of 0. No, you can't cross off the 4 because the 4 is technically to the power of 1. Only this x was to the power of 0, so only this x is going to be crossed off. So this x to the power of 0 is gone. It goes to 1, which again is the equivalent of scribbling the whole thing out and ignoring it. All right. So what do I want to do here? I want to do the coefficients. Notice that there's no coefficient here. Ooh, I want to do that with the laser pointer. No coefficient here. There is a coefficient here. So I'm going to worry about just this one. This is going to be the fraction, and I'll do this now in pen. The fraction 4 over 2, which reduces because I can divide both the top here and bottom here by 2. And that's going to reduce to 2 over 1. All right, coefficients are dealt with. Now, all I have left is x to the negative 2 and x to the power of 3. Well, which one is the bigger and more positive number? Again, which one is closer to positive infinity is kind of the question that I'm asking. X to the power of 3 is closer to positive infinity. Even if I had like x to the negative 7 over x to the power, x to the negative 7 over 1, this one is closer to positive infinity because that one's a negative. So you always choose the side that's closer to positive infinity. In this case, x to the power of 3 is bigger, and I'm like doing bigger in air quotes, but you can't see my quotes because my fingers aren't being recorded. My answer is going to be in the denominator. All right, and then I'm going to do bottom minus top, and the top is a negative 2, which means I have a double negative. The double negatives kiss and become positive, and let's go ahead and simplify this bad boy. Top is going to be 2. Bottom, we're not going to write the coefficient of 1. Again, it's more simplified to not have a coefficient if there is a 1. And then I'm going to have x to the power of 3 plus 2 is 5, and I get my final answer of 2 over x to the power of 5. Number 11, 2 over x to the power of 5. We're getting it right. Let's move on to number 12. Oh, yes, I see another power of 0. Remember, don't cross off that 2 by accident. It's just this power, or this b to the power of 0. It's going to go to 1, which, again, is the equivalent of saying that thing doesn't exist. I just have a 2. All right, unfortunately, these coefficients here, I'll go ahead and box those with ink. They cannot be reduced. The fraction 2/3 is unreducible. 2 and 3 are what's known in the math world as co-prime, meaning they cannot be reduced in a fraction. So I'm going to have to leave the 2, and I'm going to have to leave the 3. That sometimes happens. And there's nothing left in the top. All I have to do is simplify the bottom. And when I have multiplication, reviewing from our last lesson, multiplication means I'm going to add these exponents. 3 plus 3 is 6, so I'm going to have a b to the power of 6. Notice I try to make my 6's like a little bit curvy and my b's a little bit straighter. I'm not always the best at doing that, so I do read them out loud, and that does help. But there's my answer, 2 over 3b to the power of 6. Let's check number 12. 2 over 3b to the power of 6, 2 over 3b to the power of 6. Excellent. We are on to our second to last problem, number 13. Oh my goodness, there is a lot going on. And the first thing that I see, power of 0. Let's get rid of it. So I'm going to go ahead and take the liberty of just crossing the whole thing out. That's kind of what I would like you guys to do as well, to make sure that you're not making any mistakes. That thing is gone. All right, I want to deal with the coefficients first. That's usually my first step. And I mean, I could kind of reduce if you're really mentally... what's the word I'm looking for? I was looking for a synonym for quick, but if you're really good with your mental math and you're like 4 times 4 is 16, divide by 2, and you can do that all really quickly in your head and just get one final answer here, boom, you can do that. I'm going to go step by step and make sure that I get this all correct though. I'm going to simply multiply 4 times 4 on the top. That's it. 4 times 4 is in the top is 16. What's happening in the denominator? Well, I have a 2 times 2, which is going to be 4. I'm going to reduce it in the next step. You can see that 16 over 4 will reduce to 4 over 1, but for now, that's good. All right, what's going on with the top? I'm going to do this in a few different steps. I'm going to leave x, and I'm just going to add this power and this power because there's multiplication happening. Whenever you multiply the same bases, you add their exponents. So I'm going to do, this x is going to be the power of 2. I'm doing this in ink. 2 plus 2. I wanted to do it in ink, I should say. And what do we have up in the top still for y's? In terms of y's, there's no y's there because that one was crossed off. And I just have this y to the power 4, which I will copy down. And I'm going slow. I know some people want to jump the gun and start doing mixing with the bottom. You could do that if you're careful. All right. What about the denominator? I've already gotten those coefficients taken care of. I want to deal with the x first, even though this y is first. For whatever reason, it's out of order alphabetically. I'm going to do x first, and I'm going to, again, add my powers. And by the way, this y is to the power of 1, and this x is to the power of 1, because when you don't see a power, that power is 1. Let's go ahead and add all of my powers. Again, the reason that I'm adding, I have multiplication with same bases. So I'm going to add this -4 with this 1, -4 plus 1. I'm just going to write that out. -4 plus 1. That'll really show my work, right? All right, and then I'm going to deal with my y's. For my y's, I have a 1, and I'm going to add a 4 again because I'm multiplying. So 1 plus 4, I'm just going to write out 1 plus 4. All right, nice and slow. Next, I'm going to reduce 16 over 4. That reduces, because I can divide the top by 4 and divide the bottom by 4, to 4 over 1. I'm going to have x to the power of 4, y to the power of 4, x to the power of -3, y to the power of 5. I'm just adding a bunch of stuff. From here, now I have a division problem. You see the division problem with these x's happening? I'm going to choose the side that's closer to positive infinity in terms of the powers. That 4 is bigger or closer to positive infinity than that -3. So I'm going to write my x in the top. So let's go ahead and do my work down here, yeah? Yeah, all right. I have a 4x to the power of 4, and I'm going to subtract the bottom, subtract the -3. So I do have a double negative happening. What's happening with these y's? Which one is bigger or closer to positive infinity? Well, that 5 is, and that 5 is in the denominator. So my y is also going to live in the denominator. And I'm going to do bottom minus top. And that's all she wrote. We just need to go ahead and finish this off by simplifying. I can say this is 4x to the power of, okay, negatives kissed, they become positive. 4 plus 3 is going to be 7. And in the denominator, I'm going to do y to the power of 5 minus 4 is 1, but we don't write the 1, we just say y. And there's my final answer, which I will box. And then check my work. 4x to the power of 7 over y. 4x to the power of 7 over y. We got it correct. And we are on our last problem then. In number 14, oh, I think number 13 was harder than this. Look how many powers of zeros I gave you guys. I don't know if that's going to happen for a quiz, guys. Any power of 0, scribble, scribble, scribble. They're all gone. Excellent. Next thing that I see is let's deal with those coefficients. There could have been a coefficient in front of that v, but there wasn't. Lucky us, we just have this 4 over 4 that we have to reduce, and that obviously reduces to 1 over 1 because it's the same thing over itself. And what's left in the top? Nothing. So I don't write anything right there. All right, what about our v's? So I see v's there. Remember that this v is a power of 1 because you don't see any power. And then I have v to the power of 3 plus 1. Again, why am I adding? Because we're multiplying the same bases. Whenever you have same base and you multiply, that always means we add. All right, so 3 plus 1 done. And then those are done. And the last thing I have is this u squared, which I'm just going to recopy down. U squared. All right, in the numerator, I still have to have a 1 because I need a fraction. This denominator, this one I don't need anymore because I have other things to list. This is going to be v to the power of 3 plus 1, which is 4, and then just copy down the u squared, and that's as far as we can go, guys. This is going to be 1 over v to the power 4 u squared. Let's check. 1 over v to the power 4 u squared, and that concludes homework 7-2. And let's zoom out all the way. Thanks for watching, guys.